Okay, everybody. Today I'm going to show you the integral of 1 divided by x. Okay. Now, the integration is the reverse of the differentiation. So, like subtraction is the reverse of addition, multiplication is the reverse of division, and integration is the reverse of differentiation. So let's first differentiate x to the n with respect to n, with respect to x. So this is going to be equal to n times x to the n minus 1. So what do? You bring the n down over here, okay? You multiply the whole thing by n, and you repeat the x, and you subtract 1 unit from the n, from the exponent, right? And this is the differentiation. Now, if you want to do the integration, you do the opposite in the reverse order, okay? So you do this. You do x to the n plus 1, and you divide the whole thing by n plus 1 plus c. But we don't have to worry about the c for now, okay? In this example, we're not going to have to worry about the c. So what is the problem with trying to find the integral of 1 divided by x dx? What is this equal to? Well, this is going to be equal to the integration of x to the minus 1 dx, which equals, here we go, minus 1 plus 1, because you got to add 1 to the exponent. So minus 1 plus 1, 0, divided by 0. Okay, because you got to divide it by the new exponent with the 1 already added. So it's x to the n plus 1 divided by n plus 1. So x to the 0 divided by 0. Since x is not 0, okay, not necessarily 0, here you're gonna get something like this. Yeah, you're gonna get this is gonna be equal to 1 divided by 0, because x, which is not 0, to the 0th power is gonna become 1. So you have 1 divided by 0, which doesn't exist. So what do? Well, if you find a function whose derivative is 1 to the x, then you know that the integration of 1 to the x is that function. Okay, so if you find a function here, f of x, actually I'm gonna derive. So you're deriving a function f of x with respect to x, okay? And this equals 1 to the x. You know that the integral of 1 to the x dx is going to be equal to the same function here. And that's what mathematicians found out. So I'm just going to do this on this side here. Like I'm going to separate this thing here. Okay. Now, what do? Well, this function right here is just ln of x, okay? And we're going to have to prove that. So what is the derivative of ln of x? Well, if you have y equals ln of x, what does that mean? You got a base e here, which is invisible because it's the natural logarithm. This means that e to the y equals x. Okay, this is just what logarithm means, natural logarithm. Now, you want to differentiate the whole thing with respect to x, okay? But the problem is that you don't have an x here, but you know that y is a function of x. So you can do indirect differentiation, or use the chain rule, right? What are you going to do? You're going to differentiate both sides of this equation here with respect to x. All right, so what do you do on the right side? On the right, I'm just going to put an equal here. On the right side, well, the derivative of x with respect to x is just 1. The derivative of e to the y with respect to x, well, you can't do that straightforward, okay, directly, because you don't have an x here. So you're going to have to do something, I think books call it implicit differentiation. You're going to do derivative of e to the y with respect to y, and you're going to multiply this, okay, by the derivative of y with respect to x. Some people don't like to say this, but They say this is not a multiplication, but I kind of disagree. I'm not going to get into that now, but I kind of disagree. So you can cancel these two out here, and what are you going to have? You're going to have the derivative of e to the y with respect to x. That's what's going to be left. Books don't like this idea, but I think this idea is right, except that there's such a long argument, okay? So I'm not going to get into this. Now, anyway, what is the derivative of e to the y with respect to y? Well, it's just e to the y, right? It's just like when you're deriving e to the x with respect to x. It's just e to the x. So this here is just going to become e to the y, okay, times dy dx equals 1. What are you going to have now? Dy dx equals 1 divided by e to the y. And what's going to be left? Dy dx equals 1 divided by e to the y. What is e to the y? E to the y is x. Okay? So you can just say that this equals 1 divided by x. So there you go. And what is y? Y is the ln of x. So we just proved, okay, that the derivative of ln of x with respect to x equals 1 to the x. Therefore, the integral of, well, the problem is that I'm running out of space here. I'm going to do it here. The integral of 1 over x with respect to x equals ln of x. Of course, everybody's going to say plus c, but you don't have to worry about that now. Okay, it's just ln of x. And there you go. So we found the integral of 1 to the x, that's ln of x, without going through this process here. All right? That's it.